Okay, let's talk about piecewise functions, specifically piecewise linear functions. Okay, so a piecewise function is just a function that's broken into multiple parts. So for example, this function is broken into two different equations. So how this works is this. If the x value you plug in is less than or equal to 2, we'll use this equation. If the x value you plug in is greater than 2, we'll use this equation. So it's as simple as that. So for example, f of negative 1. Negative 1 is less than 2, so I'm going to use this equation. So I'll have 3 times negative 1 minus 1. 3 times negative 1 is negative 3, minus 1 is negative 4. So f of negative 1 is negative 4. Now let's find the initial value. Recall that the initial value is just f of 0. It's the y-intercept. So I'm going to plug 0 into this equation because 0 is less than 2. So 0 is less than 2, I'm going to use this equation. So if I put a 0 in here, 3 times 0 is 0, 0 minus 1 is negative 1. F of 1. 1 is less than 2, so I'm going to use this equation. Put the 1 in here, 3 times 1 is 3, 3 minus 1 is 2. Plug in 2. 2 is equal to 2, so I'm still going to use this equation. 3 times 2 is 6, 6 minus 1 is 5. Okay, let's plot those points then. So I have negative 1, negative 4. I have 0, negative 1, the y-intercept. F of 1 is 2. And f of 2 is 5. And I can plug in any point in between those so I can connect those back. Okay, so the line keeps going this way forever, but notice it has to stop here because I can only plug in numbers that are less than or equal to 2 for x into this equation. So this equation goes with this graph, but it has to stop when I get to 2. Because once I go past 2, I'm going to use this equation. All right, so let's do that. Let's find f of 3. So 3 is bigger than 2, so I use this equation. So I have negative 2 times 3 plus 7. Negative 2 times 3 is negative 6. Negative 6 plus 7 is 1. Okay, so let's plot that point. I have 3, 1. F of 4. 4 is bigger than 2, so I'm going to put a 4 in this equation. Negative 2 times 4 is negative 8. Negative 8 plus 7. Oh, excuse me. I'm going to put a 4 in that equation. So negative 8 plus 7 is 1. Excuse me, sorry. If I put a 4 into this equation, I get negative 2 times 4 plus 7. That's negative 8 plus 7 is negative 1. Okay, so I put in 4 and I get negative 1. F of 5. Okay, so 5 is bigger than 2, so I'm going to use this equation. Put in a 5, I get negative 10 plus 7, and I get negative 3. 2, 3, 4, 5, and negative 3. And of course, that's a linear equation, so I'm allowed to connect all of these, and the line will keep going this way forever because I'm allowed to plug in any number bigger than 2 to that equation, so we can keep going this way forever. Okay. What about between 2 and 3? So what if I wanted to plug in, say, 2.5 here? So f of 2.5. Okay, so if I put 2.5 into this equation because 2.5 is bigger than 2. So I will have negative 2 times 2.5 plus 7. Negative 2 times 2.5 is negative 5, and negative 5 plus 7 is 2. All right, so negative 2 times 2.5 plus 7. Negative 2 times 2.5 is negative 5. Negative 5 plus 7 is 2. All right, so 2.5, and I get 2. And I can plug in any number between there, so we can connect those. That. All right, let's get a little bit closer to 2. So let's plug in, say, 2.1. So if I plug 2.1 into this function, 2.1 is bigger than 2, so I'm going to use the bottom function. So I'll have negative 2 times 2.1 plus 7. Negative 2 times 2.1 is negative 4.2. Add 7 to that. 7 minus 4.2 is 2.8. Okay, so if I plug in 2.1, something really close to 2, I'm going to get a 2.8, which would be about right there. And I can plug in anything between those. Let's get a little bit closer to the 2. So let's plug in, say, 2.01. So f of 2.01. 2.01 is bigger than 2, so I'm going to use this equation. So I'll have negative 2 times 2.01 plus 7. Negative 2 times 2.01 is negative 4.02 plus 7. And 7 minus 4.02 is 2.98. So notice 2.98 is really close to 3, but not quite. So I plug in 2.01, something really close to 2, and I get a point really, really close to 3. Let's plug in something even closer to 2. So let's do f of 2.001. And so if I do that, 2.001 is bigger than 2, just by a little bit, but it's still bigger than 2, so I'm going to use this equation. So negative 2 times 2.001 plus 7. That's negative 4.002 plus 7. 7 minus 4.002 is 2.998. All right, so I plugged in something really, really close to 2.001, way in there really close. And I come up here and I get a value really, really close to 3, 2.998. Okay, so I'm plugging in these numbers closer and closer and closer to 2, and my answer keeps getting closer and closer and closer to 3. So how we're going to represent that, remember that we can't plug in 2 to this equation. If we plug in 2 to the function, we have to use this one. But the closer we get to 2, plugging in 2.1, 2.01, 2.001, the closer our answer gets to 3. So we're going to represent that with an open circle, like that. Okay, so this line goes all the way up here. We're going to represent that with an open circle. So at the point 2, 3, I'm going to put an open circle. Okay, so what that means is that if I plug in 2 to this function, I get a 5. I don't get this point here at the open circle. 2 gives me a 5. But if I plug 2 into this equation, just if I did, if I put a 2 here, negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. So I'm going to have this open circle at 3. Okay, so again, what that means is that if I plug 2 in, I actually get a 5. I don't get what's in this open circle. Open circle means that point's not there. So the point 2, 3 is not really on this graph. But all these little points, as close as I want to get to 2, 3, are on the graph. So for instance, the point 2.01 and 2.98, this little point right here is on the graph. So all these points, as close as I can get to that open circle at 2, 3, are on the graph, but 2, 3 is not on the graph. 2, 5 is on the graph. All right, let's look at another example of a piecewise function. This one is broken into 3 parts. All right, so let's find some points. So f of 0. 0 is less than 3, so I'm going to use this top equation. So if I plug 0 in for x, I'll get 0. So 0, 0 is on our graph. If I plug in 1, 1 is less than 3, so I'm going to plug it into this equation, and I'll get 1. So 1, 1 is on the graph. If I plug in 2, 2 is less than 3, there, and I get a 2. So the point 2, 2 is on the graph. If I plug in 3, 3 is equal to 3, so I'm going to use this equation, and I get a 3. I have that line. And I can plug in any x value I want less than 3, so this line should keep going this way forever. But notice it has to stop when I get to 3. It has to stop there. All right, let's plug in some numbers bigger than 3. So let's try f of 4. 4 is bigger than 3, but it's less than 5. So I would use this equation. So f of 4 would just be 3. All right. F of 5, let's say. I can't use this equation because 5 is not less than 5. It's equal to, so we'll have to go down here. All right, so all these numbers between 3 and 5 will require me to use this equation. Okay, so if I plugged in, say, f of 3.5, 3.5 is between 3 and 5, so it would just be 3. Okay, so if I plotted that point, 3.5 would be here, it would be 3, so just go there. Let's try maybe f of 4.5. So if I plug 4.5 in, 4.5 is between 3 and 5. So again, my answer would just be 3. So plug in 4.5 and I get a 3. So in fact, any number that I plug in between 3 and 5 will always give me 3. So I'm going to get this straight line, straight horizontal line across there. If I plugged in 3.01, let's say, tiny little number right here, really close to 3, 3.01, I would still get 3. So as far in here as I want to go, I'm always getting closer and closer and closer to 3. Okay. Now here, we won't need an open circle at 3 because 3, 3 is actually on the graph. But it's on the graph because of this equation up here at the top. I plug in 3 and I get 3. But it also, this line also gets closer and closer to that point 3, 3. So I'll just end up with a closed circle right there at 3. And, but now as I go out this way, say I plugged in 4.9. So if I plug in 4.9, that's less than 5. So I should be using this equation and I'll get a 3. So the closer I come in here, the closer I get to this 0.53. But I'm going to have to use an open circle because, let me make that a little bigger. I'm going to have to use an open circle because if I plug 5 in, I'm not allowed to use this middle equation because 5 is not less than 5. So it won't be 3. So the 0.53 is not on that graph. And let's figure out what we get if we do plug in 5. Okay, so let's do it up here maybe. If I plug in 5 to the function, 5 is equal to 5, so I'm going to put it here. So it'll be 2 times 5 minus 4. 10 minus 4 is 6. 4, 5, 6. Okay, so if I plug in 5, we get 6. The point 56 is on the graph. The point 53 is not on the graph. There should be an open circle there. If I plug 5 into the function, I have to use this equation, and I get a 6 out of it. Hey, let's plug in 6. So maybe, so if I do f of 6 here, 6 is bigger than 5, so I got to use this equation. 2 times 6 is 12. 12 minus 4 is 8. And so that would be on up here somewhere. If I plugged in a 7, 7 is bigger than 5, so I have to use this equation. 2 times 7 is 14. 14 minus 4 is 10. So that would be way on up there somewhere. I can plug in any of these numbers. So I'm going to get a line that goes up that way for it. So again, if I plug 3 into the function, I get a 3 out of it. The point 3 is on the graph because of this. 3 is equal to 3, so I use this equation, and I get 3. The point 53 is not on the graph. There's an open circle there, a hole, because I'm not allowed to plug a 5 into this equation. A 5 has to go into this equation, and that'll give me 2 times 5 is 10, 10 plus 4 is 6. So the point 56 is actually on the graph. All right, so here's a practice problem for you guys. Got a piecewise function here broken into 3 parts. I want you to find me all these values for the function, and then I want you to make a graph of the function. So pause the video, work that out, and we'll go over the solutions. Okay, so f of -2, which equation do we use? -2 is less than 0, so we will use this equation. So we've got 2 times -2, which is -4. F of -1, -1 is less than 0, so I use this equation. 2 times -1 is -2. F of 0, 0 is equal to 0, so I use this equation. 2 times 0 is 0. All right, f of 1, which equation do we use? 1 is between 0 and 5, so I'm going to use this equation. So that'll be 3 minus 1, which gives me 2. F of 3. 3 is between 0 and 5, so I'll use this equation. 3 minus 3 is 0. F of 5. 5 is equal to 5, so I'll use this equation. 3 minus 5 is -2. F of 6. 6 is bigger than 5, so I use this equation. So if I plug 6 in here, 3 times 6 is 18. 18 minus 7 is 11. If I plug in 7, 7 is bigger than 5, so I'll use this equation. 3 times 7 is 21. 21 minus 7 is 14. So let's plot some points then. So if I plug in -2, I got a -4. So that's here. When I plugged in -1, I got -2. So that's here. When I plugged in 0, I got 0. So that's there. And any x value I plug in less than or equal to 0, I'm always going to use this top equation. So I should have this line going that way forever. The middle function, let's graph it. Okay, so when I plugged in 1, I got a 2. When I plugged in 3, I got 0. When I plugged in 5, I got negative 2. You see we have a line going this way. So my slope is negative 1, so it's going down, down 1, over 1, down 1, over 1, so forth. All right, but what happens between 0 and 1? So what if I plug in 0.5 maybe to that middle equation? Then we would have 3 minus 0.5, which would be 2.5. So that would be here. And in fact, we can plug in numbers really, really close to 0, say 0.1 or 0.01. If I plug in 0.1 right here, so if I put in 0.1 to this equation, 3 minus 0.1 would be 2.9. So it would be really, really close to 3, but not quite there. So we're going to use an open circle right there at 3. And again, what that open circle means is that I can plug in x values really, really close to 0, just slightly bigger than 0, and I'll get numbers really, really close to 3. So I plug in a 0.1, and I'll get a 2.9. If I plug in 0.01, I get 2.99. Make sure you understand, if you plug 0 into this function, you have to use the top equation, and you get this point. So 0, 0 is a point on the graph. 0, 3 is not on the graph. Okay. How can I figure out where this open circle goes? Another little trick is if I put 0 into this equation, I'm not really allowed to because it has to be bigger than 0. But if I did, 3 minus 0 is 3. So I would have a point right there. Even though I'm not really allowed to, that's how you can figure out where the open circle goes. So plug 0 in here. 3 minus 0 is 3. I know I'm going to have an open circle at 0, 3. All right. 1, 2, 3, 4, 5. If I plug in 5, I get negative 2. So that's actually a closed dot. All right. What about this one? Okay, so let's graph this. If I do f of 6, I get 11, which is 8, 9, 10, 11, up here somewhere. Plug in a 7 and I get 14. It's even farther up there, so I'm going to have this steep line heading up that way forever. How do I figure out the end point of this line? So the same trick as before. So I'm not allowed to plug a 5 into this bottom function, but what if I did? What if I put a 5 here? 3 times 5 is 15. 15 minus 7 is 8. So 1, 2, 3. Here's 5. So I'm going to put an open circle right there at 8. So it should look like that. So this point is at 5, 8. But it's an open circle because I'm really not allowed to plug 5 into this equation. When I plug in 5, I have to use the middle equation, and I get a negative 2. But if I did plug 5 in here, I would get 8. So I'm going to use an open circle there. Again, what the open circle means is that I can plug in numbers like 5.1, and that'll give me something really, really close to 8. I can plug in 5.01, get something really, really close to 8. I can plug in numbers as close to 5 as I want to get, and I'll get y values as close to 8 as I can get. But I can't plug 5 in here and get an 8.